So what does this contraption have to do with chatter? Well, this fixture solves several problems, and I'm going to show you what it's all about. Welcome to Wood Stuff with Hutch, and you woodturners out there, I've got a good one for you today. I finally made this fixture for my lathe that is solving a ton of problems that I run into when doing long spindle work. I've messed around with this thought process before, but I finally got around to doing it and building it, and I'm going to share that with you today. So stay tuned and I will show you what I came up with. So this is a walnut piece that's 42 inches long. You can see that when I apply the tool, we get quite a bit of chatter. You can see that ghost image. And even though it's 1 3/4 inches square, this point towards the bottom of the piece is going to get narrower. This point at the top of the piece is going to get narrower. And the chatter is only going to get worse and more difficult to control. A spindle steady is the solution to the problem. But when you bolt it down to the lathe, you cannot move your banjo and tool rest left and right of that bolted down spindle steady. So I've taken two 4-foot pieces of angle iron that are 1/8 of an inch thick and 1 1/4 on each leg. And here you see I need a 1/2 inch bolt to bolt down the spindle steady, so I make sure there's enough space between them and take a measurement to cut a supporting cross member. In here I'm just going to mark out that dimension, which happens to be 2 3/4 inches, and then I will go to my angle grinder and cut it to length, and I will need 2 of these parts. After that, I cut a board that is a little bit taller than the banjo of my tool rest. And then I go to the headstock and mark a line, and I do the same on the tailstock. Then I went to the drill press and drilled 2 holes to fit 1/4 bolts. I held the workpiece up to the lathe and drilled a dimple, and then completed the hole with the necessary size for tapping a 1/4 thread, and that was 13/64. So I put a little oil on the tap and proceeded to tap that hole in the casting of the headstock and the tailstock, where I'm going to be attaching those cross members that I cut just a minute ago. And then I just go ahead and bolt on the cleat with that first hole, and I use that to then align and mark the second hole that I will be drilling and tapping. And now I need to cut a cross member that's going to support the long angle iron pieces, and I make this about 6 inches, just kind of guessing about how long I need it to protrude out the backside of the lathe. At this point, I removed the cleat off the tailstock, drilled some 1/4 inch holes in it, and then are using those holes to mark out the tapping holes in that longer piece I just cut. You'll notice here when I go to drill the holes, I use a clamp to hold the workpiece to give me something to hold on to, just in case that drill bit bites the metal and wants to spin it when it pops through the other side. Not to mention the metal can get really hot also. Now I just tap those holes and get ready to attach this assembly to the tailstock. But first I need to cut some notches out so that I can get my Phillips head driver bit in to attach it. And I just cut these out again using the angle grinder. And here you see the pan head 1/4 bolts that I'm using to attach the cleat to the lathe. That way I don't have to try to get a wrench or a ratchet in there, and I can just use my Phillips head driver. And then I just bolt on the cross member that protrudes behind the lathe. Now, taking the first 48-inch length of angle iron, I check to see if it'll fit, and I miscalculated. So I have to reattach the entire tailstock assembly, now on the inside of the tailstock rather than the outside. Once I've remedied that problem, I place the angle iron on the cleats and use my combination square to check the distance from the ways of the lathe bed. And once again, I drill and tap holes to attach it to the cleats. Now I take the second piece of angle iron and lay it on the cleats to mark out where I need to notch that in order to attach it to the tailstock cleat. And once again, the angle iron is the tool that I'm using for this operation. And before attaching this piece of angle iron, I just double check that my 1/2-inch bolt can easily go between the two pieces. So here I've attached the second piece, and now we're ready to move on to the fun part. It's time to test this apparatus, so I grab my one-way spindle steady, place it on the angle iron, and see how it fits. And I realize I've got to modify the spindle steady because it does not travel far enough. So I disassemble it and lay out what needs to get cut away, and again going to the angle grinder. Having extended the slot in the base of the spindle steady, I reassemble it, take a test, and sure enough, it works. Sort of, but there's some vibration on startup and shutdown. We'll give it a test and see how it works. So, moment of truth time. I go ahead and grab my roughing gouge, and after having set up the spindle steady, I take a pass. Sure enough, it's working beautifully despite the little bit of flexibility and vibration that the spindle steady is experiencing. I'm happy with that. So the chatter problem's been solved, and now I have free movement of my tool rest without the banjo being interfered with. So there you have it, a new fixture that I can actually make sure that I get my work done quickly and efficiently with less vibration, and I don't have the problem of my tool rest hitting my spindle steady, and I can move the banjo left and right, full length of the piece with no blockage. So if you like this video, if you got something out of it, please like, share, and subscribe, and I'll bring you more in the future.